let's see what you guys remember about working with fractions. Don't disappoint me because this is being recorded.
Well, you should just
Try to help you out.
No, you're not. No one ever tries to help me out. No one cares about me.
Yes, we do.
Woe is me. Yes, sí, pobrecito. 5/4 plus 7/6. Now, you guys would probably look at this and say, oh, I know this. I can find my own CD. I know what it is. Okay, no one's responding. Now I'm concerned. You don't. 12, right?
12.
Notice I didn't ask what the common factor was for 4 and 6. I asked what the common denominator was between these two fractions. Now, here's what I need you to be able to do, though, so that you can work the rest of the stuff today. 4 factors as 2 times 2. Do y'all agree?
Yes.
How does 6 factor?
3, 2, 2, 3.
It factors as 2 times 3. Now, when you're trying to get a common denominator, you're trying to get the same number for both of those denominators, right?
Same number for both.
And if it's the same number, that means its prime factorization, the way it breaks down all the way, has to be exactly the same. So when I go about getting that common denominator, I'm trying to get to have the same factors. So you see here, this has 2 factors of 2. This has a 2 and a 3. So what is this guy missing to look like this?
A 3.
If I put in the missing factor of 3 here, I change the problem. But if I put it in the numerator, I don't. Right? Because isn't 3 over 3 1? So I'm multiplying times something that is in the form of a 1. Now, this guy is okay, but this guy's not. What is he missing? He's missing a factor of 2. Now, we said that multiplication, or with multiplication, the order doesn't matter, right? Don't you have the same factors here? So doesn't that really equal 12? So when I write this guy, I have my common denominator of 12. What does this numerator become? What's the other guy?
14.
Sí, 14. 15 y 14 son qué?
29.
So we get 29 over 12. Do y'all agree? So I have to look at things in terms of factors. If I don't, then I won't be able to do anything else when I'm talking about adding and subtracting with unlike denominators. So if I have this, let's go crazy here. Let's say 3 over, he's just breathing deeply, he's not upset with me. 3 over x squared plus 7x plus 10 plus 7 over x squared minus 5x minus 14. If I look at this and I'm trying to add these guys, we must recognize that just like with regular fractions from before, I can only add and subtract when I have what? The same denominators. Do I have the same denominators? No. But look at the example that I have above it. If I can identify factors, then I can put in what factors are missing so that everybody is exactly the same. So, how do I factor this first denominator? X plus 2 times what? Times x plus 5. How does the other guy factor? X minus 7 and x plus 2, right? Now, everybody has to be exactly the same. It's like whenever you are working in I don't know, suppose you're working at some kind of fundraiser. Everybody gets the same thing in their little to-go plate, right? Everybody gets the same amount of spaghetti and sauce and salad and breadstick, right? Have you ever been to one of those little fundraisers? Everybody gets the exact same thing.
No.
You haven't been to one of those. All right. You should. You should go pick it up at a sorority house and feel totally uncomfortable because you know you don't belong there. Not that that's ever happened to me.
Oh, shoot. No, yeah.
So what's missing from this plate of food that the other plate has? He's missing the x minus 7, right? Can I just put the x minus 7 here?
No, you have to put it in the numerator.
Put it in the numerator as well. You forget that, you lose, and my sympathy goes even further lower than it already is.
8 plus 5.
And here I'm missing the x plus 5 factor, right? I'm feeling happy. So do I have the same factors in the denominators?
Yes.
So we make one big honking fraction. We put the factors down here. Don't worry about the order, 'cause I don't care. Because we're dealing with multiplication. Right? What about the numerator? What? I've got it, and here's the thing, this is where a lot of students make mistakes. I got these guys to have the exact same denominators, right? So I'm combining everything, so when I do that, this stuff is going to come down here, this stuff is also going to come down here, we're going to add them. Okay? So what I find to be pretty easy is just go ahead and distribute here. So when I distribute, I have 3x minus 21. What about the other part? Plus 7x plus 35. So what do we have in the numerator now when I combine like terms? 10x plus 14 over x plus 2 times x plus 5 times x minus 7. Now what you would want to do here is see if there's anything more that can be done in the numerator. If I look at this numerator, there is something more that can be done here. What is that? Just a common factor of 2. What would you be left with? Now, will anything cancel here with the denominator? No, nothing cancels, but you always want to see if there's more that can be done. So for us, this guy is done. Okay? What do you guys think about that? Is that good?